Hi, I'm Clark on Temptress. Today we're going to continue our series on finding the best cheap lithium iron phosphate battery available. Today's candidate that we're going to tear down is the Redodo 200 amp hour plus. As many of you know, I'm an engineer and I've developed this thing called the BankManager. Lots of people are buying it now. It's doing really well. It seems to be working for people. They buy one of these and of course then they need lithium if they don't already have lithium. I get asked a lot, Clark, what lithium should I buy? And my answer up till now has been, I don't know. Don't buy the ones I bought. They're wildly expensive. So I thought I would do this series where I'm going to obtain inexpensive lithium batteries. I'm going to tear them down, do all the testing I can imagine that I would like to do, and we're going to try to find the best inexpensive lithium to go into your system. Today we're going to look into and tear down the Redodo 200 amp hour plus. It's a battery that weighs just under 50 pounds. It has these dimensions, so that's important if you need to fit it into something. And here's how much it costs on Amazon. Redodo sent me this battery for free. I've been using it as kind of my grab battery for all kinds of projects, but I haven't really been using it for power. I like it. I gotta say I like it. I like the way it's built, the way it feels. If at the end of this video I still like this battery, this one's going right into Temptress. So let's dive into the procedure. First thing, we need to charge this battery up. Now, other reviewers are going to charge differently than I charge. I'm going to just do a little aside here. You can put power into this thing and raise it up to 14.6 until the internal BMS just has enough screams and shuts down. You will have the most power possible in this battery, but you're damaging the battery doing that. It's doing something called low current overcharge. I know it sounds funny, but that's what it's called. If you go to our sales sheet down at the bottom, my friend Conrad wrote a really good review on that. We're not going to do that. For the life of this battery, barring one test we're going to do when we have it torn apart, this will only be charged through my BankManager to 100%. I think a lot of the batteries being tested are charged to 103% or something like that. Again, that damages, we're not going to do that. So let's just set this guy up to charge. BankManagers are for mixing lead and lithium, but you know, you can use them for other things. I don't necessarily recommend other people do this, but this becomes a really good just plain charge controller. So we're going to use Temptress's power supply. Okay, we've got the BankManager hooked up now. I'm going through a little startup procedure because we don't have lead, so it's just a little trick I do. And in a second, there we go. Now we're going to hook it to my bench power supply so I can put power into this and we'll get it charged all the way up. I got that thing cranked up. We're getting 4.9 amps into the batteries, and we'll just have to give this a little bit of time. So the BankManager thinks it's fully charged. We've got it up to 100%. And now we're going to discharge it under control. I bought some of these. These are a pretty good piece of kit. I bought two of them because I felt we need more than one. Basically, their role in life is to burn power and to track it. So we hook this up to the battery and we can discharge the battery through these in various ways. I've got them set up what's called constant current. And for this battery, I felt the right discharge rate for a good test wouldn't be like 200 amps, you know, what it can put out, because that's not how you're going to use them. You're going to use them lower. Obviously, I don't want to set it at like 2 amps because I got a life. That would be 100 hours to discharge. So I chose 20 amps. Bought two of these because I don't want to push them too hard. I'm going to use two of these in parallel, 10 amps each. And at the end, we're going to get a display that tells us how much power came out of the battery. Let's hook these up. This discharge process is going to take 10 hours. You don't want to wait 10 hours. So I've already discharged this battery into these, and these, I've just powered them up. They have their memories from before, so we're going to look at the numbers now. Then I'm going to clear the memories and show you what I did. We just don't want to wait 10 hours. So these guys ran in parallel. I had them set for 10 amps. This guy saw 100 amp hours before he went down and a total wattage of 1,292 watt hours. This guy saw also 100 amp hours, 1,295 watt hours. This guy just saw a little tiny bit more energy because I had the first guy cut off at, I believe it was 10 volts, and then I let this guy continue until the BMS and the battery said he's had enough and shut down. So we add those together, and what do we get? We get 200 amp hours, yay, exactly what they're rated for, and we get 2587.8, a little over what it claims. Why that number is different from the amp hour number, which is pretty easy to calculate, is amp hours are the number of amp, the amount of current that burned. The other one is the current times the voltage. If you had a battery that held its voltage really high and then dropped off at the end, that would actually put out more watts than one that dropped down in voltage and then stayed low for a long time. So both of those numbers seem perfectly reasonable. Usually lithium batteries tend to put out a tad more than their rating when they're brand new. This guy isn't brand new, he's had a few cycles, but on top of that, remember, I'm charging him sanely, I'm not overcharging him. I give him a full-on pass. This is good. So let's get these off and move forward. Next step, destruction. I'm going to try to get the lid off. Let's see what's inside this. Let's see if this works. I might have to take it outside and get serious with power tools, but maybe. Well, it's not trivial. I can tell it's just silicon down, and I'm trying to actually keep the case intact. I do have saws, we can go at this. Let's hope it doesn't go that far, but in preservation of the table, so I could really use my BFH here, I am going to take this outside and do this off camera. So we'll be back in a minute with the top off, or I'll die trying. There we go, there we go. Chisel.
Don't drop the chisel in the ocean.
Don't drop the lid in the ocean. And don't short out the wires. There we go, there we go. If you buy one of these and ever need to take it apart, maybe to balance the inside cells after 10 years or whatever, here's the trick. Come in from this side, pry it up with screwdrivers and chisels. When you get purchased, work down these sides. It's just held together with silicone, but I gotta say I'm impressed. We'll get into waterproofness when we get down below, but I think they did this one right. Let's go back down below. I think this is a real good time to take a little pause and talk about build quality because, you know, I just got to experience it. Here's the deal with batteries and anything electronic that you want to have around like a marine environment. I'm going to talk about laptops because this is where I've seen it in spades. I buy laptops, I put them on the table, I just leave them on the table, and I get the life out of them that you would expect if it was in a house. Now I've got friends who buy a fancy Pelican case, put their laptop in, close the case, and they don't last a year. What happens is you, in the heat of the day, high humidity, you put in your laptop, seal it up, and then at night it cools and you get condensation. Condensing water is what kills electronics, not humidity. Same with batteries. There's electronics in here in the BMS. So in my opinion, a battery case should either be hermetically sealed dry, as far as that can go, or big old vents everywhere, letting the air in and out so you don't get condensation. What I don't like is that other review I did, thinking about it, I realized having a USB port on the end is just every day having it suck in new moist air and every night having that condense on the electronics, repeat if necessary. This one feels waterproof. I'll look more when I get it out, but it's a nice silicone seal all over a lip. I think they did a good job for waterproofness and they did the right level. Now, I haven't actually opened this up yet. I thought I had the lid all the way off. I wanted you to see it the first time I opened it here, but a little more tool. Emily, could I have that screwdriver? Thank you very much. Okay, a little more prying. I'm down at the hot end now. Let's try not to short things out with the screwdriver, because that could get real interesting with lithium. Gotta tell you, I tell people if you're not a little afraid, don't mess with this. I'm doing this on my boat, on my home. If I start this thing on fire, it's kind of all over for us. So I'm a little afraid. Carefully. There we go. All right. Now the lid's off. Let's see what we find. Okay. Pretty good indication that it's sealed up real well. It smells slightly of solvent, like a factory. I think this air came right from China. So I'm going to say they sealed it up pretty good. 6 10-gauge wires and 2 6-gauge wires coming, well, from the BMS and from the battery. 6 10-gauge wires coming from the battery to the BMS. Obviously the BMS is switching on the low side. And they're soldered on. For high current stuff, I don't really love solder, but it's kind of a good thing here because I got them spread out. The whole idea is heat. Oh, and of course, the BMS will have a thermal shutdown, and if things got hot enough to hit the solder, well, it's in bad trouble already because it should have shut down its transistors by then. So I think that's fine. Anyway, I'm going to go off camera a bit, get these separated and put some insulators over the end of them so that I can get rid of this lid. Okay, back to these terminals. Looks like it's a tinned, probably brass, pressing right through, bonded in with epoxy. I'd say that's waterproof. The seal around the outside is a full lip over, you know, kind of a connection. I'm going to clean the silicone out of this, and I don't see why I can't put this right back and have it just as good as new when it's done. I think their case design is pretty good. One thing I don't like about batteries lately, and it could be that cells got smaller, or it could just be bigger's better, but there's a lot of foam in them, and it just makes the battery bigger. Let's start, you know, Chinese companies, let's start making the cases the size of the cells or as close as you can be, because it takes this much more space that's unnecessary. I think I'm starting to see 100 amp hour batteries in real small cases, and I think that's a good thing. I'm going to try to get some of those through to test. If you have one of those batteries and you'd like me to test it, you know, find my email address. This battery came with a surprisingly good manual, like really well written. And one thing they said is you can mount this sideways or whatever, but don't mount it upside down. And I've had my suspicions as to why, and it looks like I'm right. Don't mount it upside down because that would put, if something slipped, the weight of everything on the BMS. The BMS is on the top. The cells are actually in here sideways. The cells don't care which way they're oriented, but structurally this could be a problem. So that appears to be why they did that. Let's see if we can get this whole thing out. All right. Huh. Okay, there was some sticky tape on the bottom holding it all in. Other than that, it's a lot of friction basically. So what do we got here? 1, 2, 3, 4, 5, 6, 7, 8 cells, but it's a 12-volt battery. So these are all going to be in pairs. I apologize for the coughing. We'll probably cut most of it out, but got COVID again, and it seems to be settled in for a while. All right, got that off without tearing any of the sense wires. Whew. What have we learned so far? Well, let's see what the labels say. These are 100 amp hour cells, obviously 3.2 volts because they're lithium iron phosphate. They've put 2 in parallel, and then of the 2s in parallel, they have the 4 in series. That gives you the nominal 12 volts, and it gives you 200 amp hours because 2 100 amp hour cells, you know, are in parallel, and they help each other out that way. I believe this is called laser welded, that they've welded the studs of the cells to the bus bars. These are good, heavy feeling bus bars to me. I think that that's adequate. Don't see any of these welds not looking good. These little wires are the sense wires, and they sense between each of the sets of batteries in series. That feeds to the BMS, and the BMS then can say, well, these two cells, what voltage is this? These two cells, what voltage is this? On down. When we talk about lithium batteries, we have to think about balance. If this battery pair, this cell pair, were to get charged ahead of these, this would hit higher voltages early, and if they hit too high of a voltage, there's like a magic number. You go off above that and they die pretty instantly. You might ask how I know that for sure. Well, I've built my own batteries and I've screwed up and destroyed batteries. So it's like that. Pops the vents and it's all over. So the BMS's job is that nuclear option. Just shut down if you go too far. Let me just take a second to say, anybody that's charging your batteries until the BMS shuts down, you are doing it wrong. BMS is to protect the cells from catastrophic damage. It is not a charge indicator. So don't do that anymore. All right, let's see what the BMS has to say. Well, it's physically large, got a big heat sink on it. We're going to test the BMS functionally by putting a lot of amps through it in a bit. So that's the real test. What I want to know here is, what is this? All of these are the electrical pickups for the individual cells, absolutely critical. This guy is the thermal pickup. Now, if this is a thermal switch, which is just two pieces of different kind of metal that go click together, then it only has one setting that it goes click on, and that really implies that the thing is going to shut off when it gets hot. That's the vital, you know. If this battery gets hot enough, it could burst into flames. It's really hard to do with lithium iron phosphate, but technically can happen. So this guy has to shut down if it gets hot. If it's a more of a device like a thermometer that can tell the temperature, it's possible this has cold temperature shutdown. And what do we have here? It is definitely a thermal switch. It's labeled 75 degrees Celsius. So this pickup is not telling the BMS anything about how cold it is outside or inside the battery pack. And looking it over very carefully, there are no other thermal pickups that I can see. So I would say this battery does not have cold weather charge protection. If you need to use this in a camper or in a house that freezes, you shouldn't just use the battery and count on the BMS to protect it. You could protect it in other ways. You could get a charge controller that will shut itself down if it gets too cold. Or possibly the best thing to do would be to put the whole batteries in a really insulated box. Styrofoam is cheap and, you know, lots of it. And then just put a 12-volt heater in it that just holds it to, like, let's say 40 degrees Fahrenheit, you know, thermostat. If you had like 9 inches of insulation and a heater, it wouldn't use much power at all to keep these batteries nice and toasty warm, real easy install, and you would never really have to worry that as long as there's power in the batteries, they would never freeze. That's what I would do personally. I trust a heater and a thermostat and foam way over electronics that may fail and may charge it anyway. So it's not necessarily a bad choice, but it's going to need you as the installer to just take care of that problem. Otherwise, I think everything in here looks quite stellar from a look point of view. Let's go a little deeper. I want to know two things about all of these cells. Now they're in pairs, so I'm only going to electrically be able to tell pairs of the cells because they're dead shorted to each other. I want to know their internal resistance to see if all of them are the same. Doesn't really matter if that resistance is a high number or a low number, relatively speaking. It's all low because it's lithium iron phosphate. It does matter if they grab some cells that are really high and some cells that are really low, because they'll actually charge differently and they'll get out of balance. And then I want to know about the balance. So first, we're going to do the deal where we check the internal resistance. And then I'm going to charge this battery a little high. Lithium batteries, let me just draw you a little graph here in the air. I'm going to put a graph on top of it. When they're discharged, let's talk about nominal 12 volts. There'll be 8 or 10 volts at the low end before the BMS shuts them down. The voltage goes up pretty fast, gets up into the 13 volt range, and then grows ever so slowly through the whole charge cycle until it gets up to about 13.2, 13.3. Then it starts going up with a little bit of speed, but it gets to a place that we call the hockey stick. Like this is the hockey stick, see the shape? And this is the hockey stick, where the voltage skies up. Where it's starting to sky up, you are doing damage. Again, don't use the BMS as a charge controller, because that's all it can do is go right to the end of the hockey stick. But we're gonna, for the only time in this battery's life, we're gonna charge it directly without a BankManager. We're gonna take it up into that hockey stick, because that's where voltages change fast. And then we're gonna compare all the voltages of all the cells in series and see if they're all the same. We're gonna calculate the internal resistance of these cell pairs. Why that's important is the manufacturer should choose a set of cells that have similar internal resistance. Now they're all really low numbers because lithium iron phosphate's low numbers. One of the things we like about it. If they just grab a bunch of cells and throw it together, and some are highish and some are lowish, they will actually take a charge differently and go out of balance. So the best thing we can expect from a manufacturer is they take like all their cells, do an analysis of all of them and line them up against the shop wall, and then grab the lowest 4 and the next lowest 4 and the next lowest 4. It really doesn't matter if it's from the high end or the low end of resistance. What it matters is that they match each other, because they're all low, as I said. So how we do this. First, we measure the voltage across the cell just open. And what I get for this cell is 3.325 volts. Then I'm going to put this 2 ohm resistor into my test jig, and that's going to let a fair amount of current pass through this. It's going to pull the voltage down, and we're going to use that to figure out what the internal resistance is. I'll do the math in just a second. So for voltage, oops, gotta hold it well. For voltage, we get 3.3 volts straight up. Let's just go through the math on this one, and then we'll run through the other ones real quick. So we had a voltage that the cell wants to be at just sitting there. Then we put this in there and got another voltage, slightly lower. Now that slightly lower voltage and the fact that this is a 2 ohm resistor, we can apply Ohm's law. We find that 1.65 amps were going through this resistor. Current going through a circuit goes through the whole circuit equally. So the battery was actually giving up that amount of current. So if we go back to the voltage difference between those two numbers, and we apply Ohm's law again, V is IR, to that amount of current, we can calculate the resistance. And the resistance comes out to be 0.15 ohms. Very, very low number, but an important number. I'm now going to run through all of these, and we'll just put the answers up on the screen. No really huge outliers, but they're not identical. It is what it is. Honestly, I haven't done this enough to really know. So as we go down and we compare more and more batteries, we'll put a table in there that says, a number that defines how far they are from each other. We've got one more test I'd like to run. We're gonna overcharge this battery a bit. We're gonna apply power to this battery until the voltage comes up into the hockey stick, into where the voltages start to change. And then we're going to look at the cell voltages and see if they're all right. They should be within 10 millivolts of each other. So let's find that out. Take my power supply and hook it to both of these. Other side will hook to the positive battery terminal. So we'll be using the BMS. We won't go too high, but let's put some power into this. So I'm going to turn on my device and crank up the amps a little bit so we don't have to wait all day. Putting in 1 amp, 2 amps, voltage is coming up, 4 amps, big battery. We'll put 5 amps in. That's all my device can do. And the voltage is coming up. It's up to 13.6. It's going to take a little while. Let's let this charge up. Okay, I charged it up until the BMS shut it down. It didn't go to 14.6, so I think we're going to find one of these cells is just a little out of balance. With the BankManager, I never noticed it because we don't go up into that hockey stick. So it's just a lot more tolerant in that world. But, well, let's find out. First cell. 3.515. Second cell, 3.499. Third cell, 3.554. Final cell, 3.428. This cell's a little high compared to these. So this battery is a little bit out of balance. This could have been poor top balancing from the factory. This could be because I've used it and it got out of balance. Remember, the resistances were just a little different. Seems a bit much to me for a battery that's so new. I wasn't able to take it all the way up to 14.6. The 14.6 would come from this voltage plus this plus this plus this. Of course, they've all dropped down a little since I charged, but that total, if these were all balanced, would be 14.6, all getting 1/4 of that. But since this guy went high first, the BankManager had to shut him down. Again, if you don't overcharge your batteries, you would never even notice this because of how that hockey stick thing goes. When you back off to 100%, you're at such a lower, safer state that you really don't notice this. Since this is going to be my battery, and since I've got it open, I'm going to put a resistor across these two cells for a little while until I discharge this pair and this one a little bit. I'm just going to nurse it and get them all right. I'm not going to bother you with that, but that's my plan. All right, I'm probably looking sweatier. I have been working on this for about an hour and a half. Didn't need that much, but I'm learning, you know. I found that these two cells were equal to each other. I found this one was charged significantly higher and out of balance, and then I found this one was lower. Looking at the resistances, there's no clear reason why this should be lower and this should be higher. I believe they may not have been balanced properly at the factory, but I played around with it. I used my resistor and my amp meter, and I brought the charge state of this one down simply by just shorting it together, running the power through this. Got a little warm, but never too warm. 2 ohm resistor seems to be a good size to use. And I brought this cell down. Now I could have brought all of them down to this point, but it was easier for me because I have this nice power supply to, with an Eagle Eye on it, because you can get in trouble charging these too high, my good fluke meter hooked to it. I charged this cell up, I charged this one, discharged this one, so they match these. Now they're all in pretty good balance. It's probably one of the problems you're always going to have if you buy a battery that someone else puts together. You're not going to know about the balance. If you do it yourself, you're going to know about the balance. This battery was particularly nice in that I could open the case without destroying it. So I'm going to kind of give it points for that. What it comes down to is if you use the BankManager approach, which I use, you're never getting near where balance even matters much. Maybe 5-6 years in, maybe it'll get attention required. Unless you charge really hard with a huge alternator. In which case, there's a procedure you can follow. You can open the case, follow the procedure, and put the case back together. It's as good as new. Not in this video, but in a video, if you guys are interested, comment below. I will go through the process of balancing a battery, top balancing a battery manually. Really isn't too terribly hard to do, but you do have to open up the case. Anyway, that's what I found. So right now, this battery's in pretty darn good condition, better than factory. By the way, I did not notice it had any dynamic balancing, any automatic cell balancing. I held it up into the voltages where that should be happening, and I just wasn't seeing it happen watching. I won't go into details, but I don't believe they have that feature. If you do open your cell balancers are something you can buy on eBay for like $10-ish if I remember, like no money. And that might be interesting to you, but that's a whole different kettle of fish. Now I'm going to package this thing back up in its case again, seal it up, and then we're going to try to pull some real big amps out of it, and then we'll give it a score. All right, we're now set up to our 3,000 watt inverter, and I'm going to put some loads on it. We've got two different heat guns. I have them placed in different parts of the boat so they're all not on the same extension, the same sub-circuit, you can understand. But we're going to bring it up to 200 amps and watch what happens. Okay, plugging in the other. And here I am. We're going to turn on we're at 123 amps. And take it up just a little over 200. Voltage came down to 12.6 volts. But it's putting out 200, no problems. And I don't know, let's give it 5 minutes. This is a lot of pull. This is right at its top rating. All right, I'm gonna shut her down now. Oh, what did it get to in voltage? 12.5554. So it's rated for 200. We run 200 through it for a goodly long time. Didn't seem to trip itself out. I say that's a pass. We've spent a very hot day running this through its paces. Now let's put it on the leaderboard. I'm going to be producing a document. It's going to be linked to from the description of every one of these videos. Go to the description, follow the link. The reason you have to follow the link is new ones are going to arrive all the time, so we can put it there. Also, there's things about this that look adequate to me now, but once I've reviewed 20 batteries, I might change my mind. So I reserve the right to move things around on the board. You should go to the board if you're going to buy a battery, and everything you need should be there, and you can make your decision based on your criteria. We've run this through its paces. Now let's give it a rating. Capacity, I say it passes. 200 amp hours, 200 amp hours. The cells, I'm going to give it a good. I think it's okay. I might reserve judgment later if other batteries look like they're balanced and chosen better. But I don't see a reason why this won't work for you. Build quality inside seems perfectly good. I like how everything's supported. I like that it more or less fills the box. They could make the box a little smaller, but it looks like they've done a good job. The case, I love this case. I liked this case a lot, how easy it is to handle. It's a 50-pound battery. I've been just whipping around using it everywhere. These things make it. But what I love about it now is I was able to get it open, do some work inside the battery, seal it back up, and it's basically as good as the day I got it. It is super waterproof. It is sealed all around. It doesn't have silly things like USB connectors or whatever to let moisture come in. I don't expect it's going to have a condensation issue. I feel that this case protects this battery as well as any case should be able to. Company, I've talked with the company on email quite a bit actually. The person I'm talking to has very good English, very good business acumen. They answer my questions. They go to obvious engineers to get real answers to more deep questions I ask. I'm happy with the company, and they have a manual, even though it's a Chinese company, that was like one of the better manuals I've ever read. So the company gets an excellent rating. It's slightly more expensive per amp hour than a few others I've seen. The case is really good. Overall value is going to be a judgment call, and honestly, I don't know yet. I'm learning. So I'm going to give it a really great, because I think it's a great battery. I'm putting this battery into my boat. I like it well enough. But maybe I'll find better ones and it'll move down the list. Keep looking at that list to find out where I place it after a year. I hope you enjoyed this in-depth teardown, and I really mean teardown, of course, of a lithium iron phosphate battery. I want to get better at this, so if there's things that I should have checked or should have reviewed or should have paid more attention in, please tell me in the comments. That way I will be a better battery reviewer in the future. I tried to do all the things I thought were important, but you know, people miss things. If you like the video, please give it a thumbs up. If you'd like to see more of our videos, you know, please subscribe, you know how that goes. And comment, share, all those things, it really helps. We've been getting a lot of new subscribers lately. Welcome to the channel, and I hope you find other videos on our channel you enjoy. Bye from Clark on Temptress.